So in this video, we're going to look at ratios and rates, unit rates, proportions, and looking at different geometric applications where we'll use proportions to find different side lengths, etc. And then you can see here the student objectives. All right, so let's begin. I want you to be thinking about what is a ratio, okay? And we can have things like 3:4, or we could write it 3:4, or we would write it 3:4. So anything that you're doing a comparison, okay? It's a comparison of two quantities by division. So then we're looking at comparing A to B, for example. We're looking at 4:1 using the colon, 4:1, or 4:1 using a fraction. So those are ways that you can write different ratios in different forms. So let's take that idea and let's go ahead and do some comparisons. The greatest snowfall record in North America in a 24-hour period is 76 inches. What's the ratio of the amount of snowfall? Notice to time. So we would write 76 inches to 24 hours. And we can simplify that. So we could divide both by 4. So that would be 19 inches to 6 hours. And that would be the ratio of amount of snowfall to time. Here's one with basketball. So of these, you got 29 free throws, and there's 27 were 2-point. 29 free throws, 27 were 2-point field goals, and the remainder were 3-point field goals. What's the ratio of the number of 2-point baskets to free throws? Well, we had a total of 64. So if we're looking at the ratio of the number of 2 points to free throws, then we're looking at 27 to 29. So whatever comes first, the free throws, in this case, it's whatever is coming. So what's the ratio of the number of 2-point baskets to free throws? So 2-point baskets was 27, free throws was 29. So that's part A. Part B, what's the ratio of the number of 3-point baskets to total? All right, well, we know that we've got the 29 and 27, so that's going to be 56. And then we know that we've got 64 total, so we know there's 8 remaining. So that would represent your 8 would be 3-point baskets to your total of 64, which would represent or be equivalent to 1/8. Here we've got a HD TV screen and approximately 46 inches in diameter with a width of 40, height of 25 inches. Find the ratio of width to height. So width is 40, height is 22.5. So now you can, in this section, you can use your calculator and you can do the division. But if I want to continue the ratio, keep it as a ratio, then what I can do is I can just multiply my n divided by n. Let's just make it 10. So this will be 400 inches, and this will be 225. Because remember, 22.5 multiplied by 10 is going to be 225 inches. Now think about dividing this, and let's see, we got 25 as a factor, so we could say 25 times 16, that'll give you 400, and 225 divided by 25 is 9, So the 25 factors will divide out, leaving you with 16/9. So 16 inches to 9 inches would be that ratio of width to height. Now, if you simplify the following ratios, so we want to say 4 8/10 divided by 10, 5 6/10 divided by 10, 40 divided by 60, and 48 hundredths divided by 64 hundredths. So 4 8/10 would be the same as 48 hundredths. And so 48, and we divide that by 4, or we might even, let's see, 100 divided by, so that would be 25. We divide them both by 4, and so that'd be 12/25. So that's as far as you can go in regard to simplifying that. It's a lot easier if you go ahead and change it by making my n divided by n 10 divided by 10. So 4 8/10 times 10 is 48. 10 times 10 is 100. 5 6/10, let's make that 56 hundredths. And if we divide 56 hundredths by 4 and 100 by 4, we're going to get 14/25. And then 40 divided by 60, well, that's 4 times 10 and 6 times 10. So the 10 factors will divide out. And then 2 times 2 and 2 times 3. So the 2 factors. So you're left with 2/3 for 40/60ths. 48 hundredths divided by 64 hundredths. Well, your n divided by n could be 100. And that would make it 48 divided by 64. And 48 is divisible by 8, so that'll be 6. That's 6/8. You could divide them both by 2 and get 3/4. And then finally, you have 128 divided by 256. And you could divide 128 divided by 8, 256 divided by 8. But you can also actually divide both by 128, because 128 divided by 128, or 128 multiplied by 2 gets you 256. So actually, this one is actually 1/2. So that's simplifying your ratios. Some extra practice on that before our meeting Thursday. I would encourage you to look at some of the practice with writing ratios and simplifying ratios. Next objective, we want to look at rates, okay? And a rate is just a comparison of two quantities. For instance, miles per hour, that's a rate. We could say pounds per ounces, or I'm sorry, pound. We could say dollars per pound. We could say dollars per hour. Some people have hourly jobs, some people are salaried, so you've got different ratios and your different rates. So again, you could do your distance over time. That's kind of like that miles per hour. So any type of measurement that we can compare two quantities. We could do miles per gallon. That would be a rate. So if I have 504 miles to 18 gallons, what's the mile per gallon? And so you're just dividing that 504 by 18, and that's going to give you 28 miles per 1 gallon. And then if David owns a car that's so he gets 475 and 4/10 miles per 16 and 8/10 gallons. Well, we just divide 475 and 4/10 divided by 16 and 8/10, and you're going to get about 28 and 29/100 miles per 1 gallon. So it's not much at all difference. The numbers do come out different, but not much difference in those in the Toyota Sienna and the Honda Odyssey. Walmart employees, certain Walmart employees could earn $470 on a 40-hour work week. So 470 divided by 40 to figure out the rate of pay per hour. So notice where we're continuing to go with this. 470 divided by 40, $11.75 per 1 hour. So these are different rates. And this is the special one. It's called a unit price, or that unit rate. So anytime you can get the denominator to be a number of 1 unit, then you know that you've made it to, or have written that in the form of a unit rate. So $5 per 1 pound, 85 miles per 1 hour. So those are, as the example says, could be 40 students to 1 teacher. As long as you get that denominator to be 1, then you've written it in the form as a unit rate. So if we're going to look at the unit rate of different sizes, so I want the unit price, which means I want to figure out the price per ounce. So if it's $2.49 divided by 10 ounces, I'd like to know what that would be as a unit rate, and that would be about 25 cents per 1 ounce. Take $3.59 divided by 16 ounces, and your result is approximately 22 cents per 1 ounce. And remember, all these unit prices are per 1 ounce. So this would be 22 cents. If you take $4.09 and divide it by 20, you're going to get approximately 20 cents per ounce. And if you take $6.79 and divide it by 32 ounces, you would get 21 cents per ounce. So go ahead and, if you're looking for the unit price, then you're trying to figure out how much per 1 it would be. If watering a lawn adequately requires 623 gallons for every 1,000 square feet, you do that division, and you're going to get 623 thousandths gallons per 1 square foot. So it's wanting the rate in gallons per square foot. So here we have a rate, and you simplified it to the unit rate. Human heart rests and beats at an average of 4,200 beats per 60 minutes. So just take 4,200 and divide it by 60, and you're going to see that you get 70 beats per 1 minute. So here's your unit rate. And this one is your rate. It's comparing beats per minute, but this is your special rate because it's down to 1. You're figuring out what it is per 1 minute. So I would go and practice these if it's needed. Look at some of the videos, look at some of the links that would give you some practice of changing from a rate to a unit rate. When we think about proportions, this is just, it represents equivalence. And it could be of 2 or more ratios, but of at least 2 ratios. So for instance, if we have, 5/15, 1/3 is equivalent. These are equivalent ratios, but at different parts. One you've got out of 15 and one you've got out of 3 parts, but their ratios, their fractions are equivalent. So you could look at and determine if these are proportional. So part A is, we're saying 1/2. Is it proportional to 3/6? And the answer is yes. 2/5 is equal to 4/7. Well, 2 times 2 is give me 4, but 5 times 2 does not give me 7. So part B is a no. It's not. They're not proportional. 3/4, 6/8. 3 times 2 is 6. 4 times 2 is 8. So you could look at it that way. So this would be a yes, they are proportional. And then 1/4 is equivalent to 10/39. Well, 1 times 10 is 10. 4 times 10 would be 40. This gives me 39. So this is a no. It's not equivalent. One method of trying to determine what the value is if you're given a proportion. So I'm just kind of going through the example that's given. A couple ways to do that is first, kind of the reason why you do it is I want to solve for x, and I see x is divided by 5, so I want to multiply both sides by 5. Well, what that does is it allows me to multiply these fractions together, which would be 5 times 9, all divided by 15. And these 5s divide out. So this is what you're left with. 5 times 9 divided by 15. Well, with cross products, you can do the same thing. We're saying that you can do cross products, and look what you get. 9 times 5 is 45, and 15 times x is 15x. You're going to divide both sides by 15. Well, what is 9 times 5 over here? Well, that's 45. You're still going to divide by the coefficient. So I don't care which method. This is a very common method, is your cross products, as opposed to your multiplicative property of equality here. Either one gets you to the answer. It's really whichever one you like to work. So if you've got 6/15 is equal to x divided by 20, if you multiply both sides by 20, you're going to have 20 times 6 divided by 15 to figure out x. Or you can do cross products and say 6 times 20 is equal to 15x, but then you're going to divide by 15. So if you'll notice, the work you get right here is the same as the work that you would get there. So if we solve the following by proportions, we could do cross products. So 3 times x is equal to 7 times 5. So 3 times x is equal to 35. So we're just going to divide 35 by 3. And we will get a repeating decimal. So x is 11 6/10 repeating. Or we could have said x is equal to 35/3 and just leave it. If we do cross products, we'd say 15 4/10 y is equal to 7 7/10 times 2 2/10, which is 16 94 And we're just going to divide both sides by 15 4/10. And when you do that division, you're going to get y is equal to 1 1/10. So if you have 8 divided by x equals 5 divided by 3, cross products, 8 times 3 is 24, 5 times x is 5x. So we're just going to divide both sides by 5. And you would get 4 8/10 to equal x. Same idea, more solving proportions. So think about this one here. It's 1 times x is x. 7 times 2 is 14. Here we've got 5 times x is 5x. And then what is 1/3 multiplied by 3? You're going to get 1. So divide both sides by 5. You're going to get 1/5. This last one, or this third one, you're going to do 2 times x is equal to 7 1/10 times 11, which would be 78 1/10. And then you're just going to divide both sides by 2, and you'd get 39 5/100. And then the last one, 8 times y is 8y, and 2 4/10 times 6 should be 14 4/10. When you divide that by 8, you're going to get 1 8/10. So cross products is an efficient way to do that. But hopefully, back to these points that you kind of understand, well, using the multiplicative property of equality, if I multiply, in this case, if I multiply both sides by what's in the denominator, then I have to do it to the other side. So I'm still going to get the same product as if I was doing cross products. So I would encourage you to work some practice problems if needed. And we looked at solving some proportions, so we'll look at some geometric applications. Matt's treadmill reading says he burns 108 calories for 24 minutes. If he stays at that rate, how long if he just went ahead and worked 30 minutes? Well, you're just going to do the same. Do cross products, 108 times 30, you're going to get 3,240. 24 times x is 24x. So when you divide both sides by 24, you're going to get 135 calories. So 135 calories divided by 30 minutes should be the same as 108 calories divided by 24 minutes. If 2 shirts can be bought at $47, then how many shirts could be bought at $200? So again, as long as you're comparing everything correctly and being consistent, 2 times 200 would be 400. 47 times x would be 47x. And when you take 400 and divide it by 47, you're going to get how many shirts can be bought? Well, it would be at least 8. And, well, I guess we would say at most 8, because we would get 8.5. And we're not going to have half a shirt. So we'll say at most 8 shirts would work. So if this student, mathematics teacher, grades are directly proportional to the amount of study time, if that were the case, Brent studies for 15 hours for a final and gets a score of 75. At this rate, what score would he have received if he'd studied for 18 hours? So if they're proportional, then we can set them up this way. And so we can do 15 times x is 15x. And 75 times 18 is 1,350. And when we divide that by 15, we would see that if it was proportional, that Brent would have got a 90% if he had just studied 3 hours longer. A Volkswagen Beetle will travel at 495 miles on 16.5 gallons. So what if if he's going on a trip and there's 1,650 miles, how far can it be driven on 130 gallons of gas? So part A is, well, how many gallons of gas will it take to drive this? So there's a cross products would be 495 times X, and 1,650 multiplied by 16 and a half is going to be 27,225. If we divide that by 495, we're going to get X equals 55, which would mean how many gallons of gas would it take to drive that long? And so on part B, if we know that there's 495 miles on 16 and a half gallons, then how far could you go on 130 gallons? So now you're just figuring out, well, that would be 495 multiplied by 130, and you're going to get 64,350 is equal to 16 and a half multiplied by X. So divide 64,350 by 130, and you're going to get 495 miles. College advertises that student to faculty ratio is 24:2, student to faculty. If there's 81 students registered for Spanish, how many sections would you expect to be offered? Well, if there's 81, so you do 81 times 2, which would be 162, divided by 24, and we would have 6 7/75. So probably 7 sections. It may not be full, but we'll probably want to offer 7 sections to continue with that rate. So Roy bicycled 234 miles in 14 days. At this rate, how far would Roy bicycle in 42 days? So we would take 234, multiply it by 42, and 14 times X is equal to 9,828. I want to divide that by 14. So X is 702 what? 702 miles. And so on a map, you've got a 1/4 of an inch represents 50 miles. If the cities are 3 inches apart, 3 1/4 inches apart, how far are they on the map? So this would be 50 if I did cross products multiplied by 13/4. Notice I changed 3 1/4 to an improper, and then 1 1/4 multiplied by X. So 50 times 13 is 650 divided by 4 is 162 5/10, which is equal to 1/4 X. So I'm just going to multiply both sides by 4, and that would be 650 miles in reality. So that's going to end part 1 of this, and then part 2 will be a shorter series, but it'll involve geometric shapes and how we can use proportions to help us solve side links to different triangles or different shapes.